it says, for the study, the sample mean was 11.3, and the standard deviation was 1.6. And the significance test yields a p-value of 0.0016. So how do we interpret this? Well, as we interpret it, what this is saying is if, if the mean hemoglobin of Jordanian children is really 12. There is a 0.16% chance of finding a sample of 50 children with a mean level of 11.3. So in our second part, they tell us in our conclusion if alpha is 0.05, so here actually they tell us, I guess, in the previous one they didn't. They say, hey, what if our alpha is 0.05 or 0.01? What would you conclude? It actually doesn't matter in either case because our p is less than that alpha. So in both cases, not chases, sorry. In both cases, we would reject H0 because our p-value of 0.0016 is less than alpha equal to 0.05 and alpha equal to 0.01. And conclude that we have evidence that the mean hemoglobin level of Jordanian children is less than 12. Was it grams?
Yeah.
Grams per deciliter. So sometimes when you try to draw a conclusion, you make a mistake. Happens all the time. So you have to be careful. And there are two kinds of main errors that you can make when you have a test of significance. So how do you know if you're making the correct decision? Sometimes we don't, and we make the wrong one. There are two kinds. A type 1 error is when you reject the null hypothesis and you're wrong. It was actually true. So if you reject it and you're wrong, that's called type 1 error. A type 2 error is when you fail to reject it and you should have rejected it.
Which one's worse?
Type 2 step.
I don't know if you could say one's worse, Aaron. I'm not really sure.
You're wrong.
Wait, so are these like errors on our part, or like they gave us like
Based on your p-values and the alpha significance. So you do your sample, and you find your information, you're like, oh, my p-value in Jordanian children was 0.0016. So I'm going to reject what they told me about the hemoglobin. Oh, you're wrong. It actually was 12. That's a type 1 error.
Is that our problem?
Well, if you're getting paid to do your job, it's always your problem.
We're not getting paid.
Are you going to pay us?
No, as far as taking the test in our class, it's not your problem because what you'll do is you'll find out what the probability of making the type 1 error is and you'll talk about it.
But it's like the statisticians who get this that make that mistake, right? Not
Yes.
us. Okay.
Well, if you're the statistician, then it would be you.
Okay.
Okay, so the chart down below talks about a visual way to see what a type 1 error is and what a type 2 error is. So now we're going to put it in the context of a problem and talk about in context, because stats is really into the context of stuff because it's drawing conclusions about information that you have. So in our example here, we have a manager of a fast food restaurant, and they want to reduce the proportion of drive-through customers who have to wait more than 2 minutes because it's fast food. And so based on the store records, the proportion of customers who had to wait at least, which means more than or equal to, 2 minutes was 0.63. That's more than half. To reduce this proportion, the manager assigns an additional employee, because hopefully this will speed things up, to assist with these drive-through orders. During the next month, the manager is going to collect random samples of the drive-through times and test the following hypothesis. So your null hypothesis is that your proportion that are waiting at least 2 minutes is 0.63, and the alternative is going to be that it should be less than 2 minutes, or we're going to find some kind of sample that has less than 63% of the people that wait less than 2 minutes. That make sense? So 63% are waiting right now, at least 2, and we want to have some kind of conclusion that adding this person made it less. So you conduct this experiment. P is your true proportion, or the population proportion, of drive-through customers that have to wait more than 2 minutes. So let's talk about the type 1 and type 2 errors, and what's the consequence of each one. So let's talk about type 1 first. So the type 1 error. Would be if the manager decides that the true proportion of drive-through customers who wait more than 2 minutes has been reduced when in fact it hasn't. Thanks. So when we talk about probabilities, the probability of a type 1 error is always alpha. Thank you, Aaron. The probability of a type 2 error is always 1 minus the power. You don't have to calculate the power. They're going to give it to you. But you have to understand that that's how you would find the probability of this type 2 error. That's what it's saying down below here, the probability of this type 2 error. The power is a specified value, and it helps you calculate the type 2 error. That's really all I want you to know about what the power is. So this probability of the type 2 error that they talk about, 1 minus the power, works like the following when you look at your distribution. So as you look at your distribution, what you see up here is you find out your p-value is 0.08 being true. This is your sampling distribution. And then you notice that your alpha, they tell you, since we don't know what the alpha is 0.05, so your probability of the type 1 error is 0.05. Down below, they tell us that our power, somewhere, do they tell way down below? And I see the 0.75, but I don't even know where they is. I thought they would have wrote down the power. Okay, so I guess that they don't. Oh, there it is. So they tell us the power right here is 0.75. So if I want to find the probability of my type 2 error, I just take 1 minus that, and this is the probability of my type 2 error. 0.2483, whatever. And I just wanted you to know that when you're trying to find the likelihood that you make a mistake or the probability of a type 1 or type 2 error. The easiest one is the type 1 error. It's always alpha, and the probability of your type 2 error is 1 minus your power. Okay, and they will give you the power. So big idea today, test of significance. It's going to end up being like the stuff we've done in the past with the state, plan, do, and conclude. Today we just delved into kind of the general idea of what it is with the null and alternative hypotheses. And then we talked about we could use proportions or means to do that. Tomorrow and Thursday we'll get into doing the whole test of significance.
Wow.